So in this case, we are going to consider our typical exam revision for our mathematics N2, which is the paper which was written actually in November 2024 exams. So we want to consider and see, guys, how you were supposed to attempt these typical questions. So make sure that you go through the instructions of the question paper. All right, so without wasting time, I'm going to quickly rush through the questions so that we can see how we're supposed to answer these questions. On question number one, let me just have a space here. We were given 1.1 when 9 is deducted from 6 times a certain number. All right. There are two statements there that we are given. All right. Then the result is minus 75. Calculate the value of the number. So when you are given this type of a question, assume that there's a certain number there that you do not know. That number can be called X. You can refer any letter of your choice. So in this case, I'm going to choose X. All right. So let us just say, let the number be X. So I'm just going to use X. Let the number be X. So if we have a number which is called X, we know to deduct is to subtract. All right. So meaning to say it was being 9 was subtracted from. Okay. There's a statement there from. Let's go back to normal values. 3 subtract 3 from 7. What does it mean? Subtract 3 from. This is the most important part. From 7. It means we are going to start with this from. You start from that number, from this, from 7. So it means 7 minus this. Remember, we are supposed to subtract 3. To subtract, that's a minus. So that's 7 minus 3. From. So if we understand this statement, guys, here they're saying we are going to subtract 9 from 6 times a certain number. 6 times a certain number. So that is, our number is what? Is X. So we are going to have 6X. Remember, from. So it means 6 times the number minus, what are we subtracting? 9. That is the case there. When 9 is subtracted, from 6 times a number, the result is minus 75, meaning to say it is equal to the result, meaning to say that's equal to minus 75, just like that. So guys, you see, they just give you simple statements there. It's a simple English that you just need to put through to understand that. All right, so once you've got the question, once you've got the equation, you can solve for X. X represents the number that you're supposed to calculate. So by solving for X, we are calculating the number. So simply solve for what? For X. That's a linear equation that we are given there. So we can simply take the minus 9 to the other side of the equation so that it will add there. So it's going to be positive 9, meaning to say minus 75 plus 9, that's minus 66 from your calculator. So you can simply divide by 6. Remember, this is a product. So dividing by 6, that's obtaining the value of X, which was going to give us negative 11. So that is the number that we're talking about. So the number, or is the value of the number that we are talking about here, which is the unknown, is minus 11. All right, so questions can be like that. Like I said, just revise as much questions as you can. Then on 1.2, you are given to solve for x in the following equation. All right, but they did not end there. Take note. Yes, you are solving for x, but they are giving us a certain statement later on by the quadratic formula method. By the quadratic formula method. All right, let's go to our formula sheet so that we see what they are talking about. Remember your quadratic formula. This is your formula sheet. Remember your quadratic formula. As we refer to our quadratic formula, what is it that we understand about our quadratic formula? Here, the roots are given by this formula. X is equal to minus b. This is our quadratic formula. So they are saying we are supposed to use this formula. And as we do understand that quadratic formula they are saying we are supposed to use there, it is supposed to be used when we have an equation like this in this format. Ax squared plus bx plus c is equal to 0. That's why we use this formula. But look at this. We do not have that. This is not the basic equation. So there's something that we need to do there. All right. So I'm just going to rewrite our question there. That's 1.2. So we are given 3 minus 5x. That is raised to the exponent of 2 is equal to 2x plus 2 raised to the exponent of 2. But they want you to use the quadratic formula. So meaning to say, we are supposed to formulate the quadratic equation ax squared plus bx plus c. How can we formulate this quadratic equation? Expand the brackets. We have to expand the brackets. So the expansion of brackets, guys, there is going to be, let me explain this, guys. Remember, I said before, if you are given a minus b squared, it is equivalent to a squared minus 2ab plus b squared. These are called algebraic identities. You can also go through your videos for grade 10 so that you understand more about this. But I also explain this. So if you are given this format, we have our A and our B, and you understand this identity, it's going to be easier for you because you know that your A is the first term, that is A squared. So our first term there is what? Is 3. So meaning to say we are supposed to have first term 3 squared, which is what? Which is 9. So we're going to have 9 minus 2ab means minus 2 times our A. Remember, our A is the first term, which is 3. Then B represents the last term. Let me properly indicate here so that we'll be together. So this is what I'm trying to say here. This is your A. This is your B. All right. The sign is already included there. The sign, the minus there. It is already included in this identity. So do not include that. Do not include that in your calculation. You take this one as your A, this one as your B. Take note. All right. So I was saying here, the identity says we are supposed to have minus 2 times A, which is our A there. We say it is what? Is 3 times B. And our B there is what? It's 5x. So you're going to multiply to 5x. So doing this, guys, we can see that minus 2 times 3 times 5 was going to give us minus 30. So that's minus 30x. All right. Then the last part that we have on this identity is the last term squared, b squared. That is our last term. Remember, our b, according to our question, is what? Is 5x. So we are going to square that, 5x squared. So that's 5 squared, which is 25. X also raised to the exponent of 2. So that's 25 x squared. So this is it. We have expanded the bracket. This is equal to, you move on to the other bracket. So let's say you do not understand this, guys. You can easily expand 2 brackets. 3 minus 5x into another bracket, 3 minus 5x. You distribute, 3 multiplies everything in the second bracket. Minus 5x multiplies everything in the second bracket. You collect the like terms. Still, you are going to have the same answer. All right, so make sure you prove that way. All right, we move on to the second part. Again, we use the identity, but this time there's what? A plus. So our identity, when it is a plus, what does it state? All right, when there's a plus, a plus b squared is equal to what? A squared plus 2ab plus b squared. That is the first term squared plus 2 times the first times the last plus the last term squared. Just like that. This is your identity. If you know this, you're not going to struggle because you understand that the A is 2x. The B is what? Is the 2. This is what we have according to our question. This is our A. This is our B. So the identity states that we're going to have A squared. And what is our A? Our A is 2x. So that's 2x squared. 2 to the exponent of 2, that's 4x squared. So there we're going to have 4x squared. Everything is raised to the exponent of 2. Then we move on to plus 2ab. So that's plus times a. Our a is what? Our a is 2x. What about our b? Our b is 2. So you multiply 2 times 2 times 2, which is what? Which is 8. So it's going to give us 8x. Remember, we've got x there. All right. Then we move on to the last part. The last term squared, that is b squared, is the last term. And our b there is what? Is 2. 2 squared is what? Is 4. So that's it. We have expanded these brackets using algebraic identities. You're supposed to know these ones. Or you can expand using any way that you understand. But at the end, you're supposed to have this after your expansion in any way that you understand there. But like I was saying, we need this quadratic equation. And as you can see, it states that one side must be equal to 0. So in this case, we are supposed to move either these terms to the other side of the equation or to move these terms to the other side of the equation. One side must be equal to 0. So in this case, I'm going to move these terms which are on the right-hand side to the left-hand side, all right? So let us transpose the minus the 4x squared to the other side. It will be a minus, remember? It was a positive, so it will be a minus. So it means 25. It's going to be 25 minus 4, which is 21. So that will be 21x squared. All right. Then we do the same thing on this 8x. We take it to the other side. So 8x, it was a positive, so it's going to be a negative. So it's going to be minus 30 minus 8, which is what? Minus 38. We have got x there. Then we move on to the constant. We are moving every term 4 to the other side. When it crosses the equal sign, it becomes a negative because it was a positive here. So it's going to be a negative. So that's 9 minus 4, which is what? Which is 5. Just like that. So this is equal to 0. We have moved everything that we had. We moved everything that we had from that side. So there's nothing left. That's equal to a 0. This is what we wanted. The quadratic equation, this one. This is what we want, this one. The format, this. So that we can use the quadratic formula. We cannot use the quadratic formula if we do not have this format. It is used when we have a quadratic equation written in this format. So once we have your quadratic equation, then you can use the formula. Insert the values there. All right. So what is our formula? Stating. All right. So just gonna substitute our values. All right. Let's just hope. I hope it's network. All right. I think back. All right. So let us substitute our values. Remember, I said our formula is x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. This is the formula, but from our equation. So we're going to insert our values. That is ax squared, bx, then this is our c. So meaning to say we are going to have x is equal to minus b. Our b is minus 38, the coefficient of x. So that is minus 38 plus or minus the square root of b squared. Remember, your b is minus 38. So that's minus 38 squared minus 4 times a times c. So we are going to have our a, that is 21, and our c is the constant, that's a positive 5, this one. So that's a positive 5, just like that. So this is the most important part that you are supposed to have. All right. Substituting the values, then everything that you're given is over what? 2a, which is 2 times what? 2 times 21, just like that. So I always advise you guys to simplify what is under the square root, these values under the square root. All right. Just ignore the square root there. Insert the values only that are under the square root. Simplify those values and see what are you going to obtain. All right, so this is what I'm simply trying to say. Let's just hope my screen is gonna be able to share. All right, so this is it. That's minus 38, minus 38 squared. These numbers under the square root. Minus 4 times 21 times 5, like this. So as we can see, we're going to obtain 1024. All right, so that's 1024. So x is equal to, remember, a minus and a minus gives us a positive. Minus, minus, that's a positive. So that's 38 plus or minus the square root of. We simplified everything there and obtained 1024. So this is over 2 times 21. That is going to give us 42. So with this, we can use our calculator now to simplify everything. So separating, starting with a plus, our x is going to give us 5 over 3. All right, let's just use this together. Our calculator is there, guys. Remember, we are now having a plus 38 there. So that was going to be, just put a fraction, gonna have 38 plus the square root of 1024, like this, then over what? 42. All right, so that is going to give us 5 over 3. So that's 5 over 3. Then we move on to the negative. Just move this, remove the positive to a negative. That was going to give us 1 over 7, or x is equal to 1 over 7. So these are the possible values of x that we are going to obtain by solving that equation using the quadratic formula at the end. Factorization was going to be possible, but we are told the method to use. So you cannot use the quadratic formula if we are not having an equation in this format. We need the format of the quadratic equation first. Then we can use our quadratic formula to solve that. All right. So that is what we had, guys. Be very careful. The method that you are being given to use. On 1.3, we are given a lady bought a dress, which is D, and 2 pairs of shoes. So a pair of shoe is given by P, all right? But she bought what? 2 pairs. So here is just a dress, meaning to say it's 1 for 1,500 Rand. However, when she approached another shop, she bought 4 dresses this time and 3 pairs of shoes for 4,500. What is the average cost of a dress and a pair of shoes? So guys, they are testing you. They want you to understand formulating equations. That's a word problem, leading us to simultaneous equations. We've got 2 things that we are dealing with. All right, I'm just going to try to attempt it here. Remember, a dress is given by the letter D. Then we have got a pair of shoe. That is the pair of what? Of shoes there is what is given by P. So the first condition, she bought a dress, meaning you say it's 1. That's 1. She only bought 1. So it's just like this, 1D. Remember, address is what is given by D. So it's just like 1D, which you can just like write like D. And we are going to add. So and a pair of shoe, that is, and two pairs there. There are two pairs. So that's 2P. Remember, a pair of shoe is what? It's P. So that's 2P. For what? For 1,500. So that's equal to 1,500. However, when she approached another shop, there she bought what? 4 dresses. It's another condition. It's another equation. So this one, it's a statement on its own. It's an equation. In another shop, she bought 4 dresses. So that's 4D. And 3 pairs of what? Of shoes. That's 3P. For what? For 4,500. We have formed an equation from there. I'm going to call it equation 2. And what type of equation are we given? Simultaneous. So by solving for D and solving for P, we are finding the average cost for a dress and the average cost for a pair of shoes. So that's it. This is what we have, guys. So let us solve our simultaneous equations. As we know, our simultaneous equations, guys, I'm going to use substitution method. Working with equation 1, you can use any method of your choice, elimination, whatever that you want. But as for me, I'm going to use substitution method. Using equation 1, I'm going to make D the subject. So from equation what? From equation 1, I'm going to make D the subject. So I'm going to take 2P to the other side. D is going to be equal to what? 1,500 minus this 2P to the other side becomes a negative. So that's minus 2P. So this is another equation that I have formed. I'm going to name this equation 3. So with equation 3, I'm going to substitute that equation 3. So I'm going to substitute equation 3 into equation 2. Take note, we made the subject from equation 1. Here, from this equation. This is where we made the subject. So you substitute in the other equation, not from the one that you made the subject, but in the other equation. So we are going to substitute equation 3 into equation 2. All right. So let's substitute, guys, and see what we are going to have. In place of D, this is what you're going to substitute. So there we are given 4D, that is 4 into value of D, this expression that you're given, which is 1,500 minus 2P. All right. Then we have got plus 3P is equal to what? 4,500. That is what we have. So after forming this equation, we can solve it. This is now a simple linear equation in terms of P, in terms of one unknown value, which is P. So you can expand the brackets, collect like terms. All right, so let's distribute this bracket that we are given here by multiplying by the number outside of the bracket, which is what? Which is 4. So that's 4 times 1,500. It was going to give us 6,000. 4 times minus 2P, that's minus 8P. Add 3P. This is equal to 4,500. So let's collect the like terms. So we can consider this part of the variables. Here we got minus 8P and 3P, right? So if we add those two, minus 8 plus 3, that is going to give us minus 5P. You take the 6,000 to the other side of the equation. So it's going to be negative 6,000. So 4,500 minus 6,000 is what? That's minus 1,500. All right, so just like that, divide by negative 5, divide by negative 5. So P is going to give us what? Negative, negative, that's what's gonna 3. So that's 300, or you can just use your calculator. So if you're to consider, you'll see that a pair of shoes, the one pair of shoes is going to cost 300 rand, because there we are talking of the cost. P, remember, that is representing the pair of what? A pair of shoes. So meaning to say a pair of shoes is for $300, 300 rand, this one. This is what you're going to have. Then we move on to the other part to find D. So you can easily use this equation 3 because already D is the subject there. Already we have got D as the subject. Yes, you can now you can substitute in any equation. You can use equation 1, you can use equation 2. You can use equation 3. So equation 3 is the best because already D is the subject there. D is equal to what? D is equal to 1,500 minus 2p. This is what you're given, minus 2p. So you just have to substitute the value of p that we calculated. So that's 1,500 minus 2 times p, which is 300. So D was going to give us 900 at the end. This is 600, so it's going to be 900. So meaning to say, at an average cost, a dress was going to cost 900 rand. That was the cost of a dress. And the cost of a pair of shoes was going to be for what? 300 rand. This is the condition. So you can conclude in that manner. So there, it was the issue of formulating equations from the statement that you're given, which was leading us to simultaneous equations. All right, let's see another part on 1.4. You are given this formula, and from this formula, they want you to make y the subject of the formula, given that t squared over t is equal to x squared over q minus y squared over c, like this. And they want you to make y the subject of the formula. All right, we can easily make y the subject of the formula in this case, all right? Because we can see the part that we have is in the numerator and it's a single term. So it's easier for us to make y the subject. All right, let's first have this to be positive. Let's just try to make this a positive term. So we are going to take it to the left-hand side. So that is going to be y squared over c. The moment we transpose to the other side, it becomes a positive. This is equal to, we have got x squared over q already on the right-hand side. Then we are going to take this to the right side. All right, remember we moved this to the left side. So we are going to take the t squared over t to the right side. So it will be a negative there. So it's going to be negative t squared over t. If you can notice, the y that we have, like I said, is in the numerator, and it's easier for us to make the subject because here we can simply remove the c that we are given in the denominator by multiplying by that c. Remember, it's in the denominator, so just multiply by c, just like c over 1. So this side, you multiply everything by what? By c. Everything, just open a bracket, multiply everything by c. So that was going to cancel, and we've got y squared is equal to. So this is a bracket multiplied by c. So you can even start by that c, like this, c into x squared over q. You can even write it this way, minus t squared over t, like this. You can even write it that way. You need to determine or to find y there, to solve for y or to make y the subject. But this is y squared. So we have to introduce the square root to remove the square. So that's the square root both sides. So therefore, you are going to have, we're going to have our y as the square root of, so that's the square root of everything that you're given there. So that's c into x squared over q minus t squared over t like this. So we're just going to open and close that bracket. So that is the condition. We have y as the subject. You can even write plus or minus if you want, or you can just have it that way. So meaning to say, we can actually make any letter the subject of the formula, depending on the condition. And also you can expand this bracket by c if you want, or you can just leave it like that. Y is already the subject, so simplification is not necessary. If we consider 1.42, they want you now to calculate the value of y in that case. If you are given that c is minus 5x, so we are already given values. All right, remember here we have we already have y here as the subject. So it is just a matter of substituting the values into the formula that you have what? Formulated for y here. All right, so that's our 1.42. So y is equal to the square root of c. According to this information, c is what? Minus 5. So that's minus 5. Open the bracket. We've got x squared. X is 1, 2. So that's 1, 2 squared over q, which is our q there is 5, minus t squared. We need the bigger one, the capital letter T, this one, which is what? 5, 2. So that's 5, 2 squared. Everything over T, the small letter T there, which is what? Which is 7. So you just have to make sure you have done a proper substitution. That is the case. It was just a matter of substitution there. Already, y is the subject. So you substitute. Use your calculator to simplify. It's just 1 mark there. So just use your calculator at once. It was going to give us, that was going to be 4,22, 779, something like that, which is going to be 228 to 3 decimal places. Considering to 3 decimal places. Remember, you can even fix your calculator direct to 3 decimal places. So questions can be given in that manner. You make the subject of the formula, then from there, they want you to make a substitution. So that was our question 1. Then moving on to question 2, we are being asked to simplify on 2.1 the following algebraic fractions and factorize your answer completely. Meaning to say, your answers, they're supposed to be in simplest form. Your answers, they're supposed to be in simplest form. All right, so that was our first fraction that we need. Actually, the fractions that we have there on 2.11. Let's just try to have it here and see. Or let me just have it aside here, guys. All right, so that's 2.11. We are given. It was 6x over 3. Everything over x squared minus 8x plus 16. All right, which was divided to 4x squared minus 1 over x squared minus 5x plus 4 times x minus 4 over 6x minus 6, like this. So remember, these are fractions, and we have got a division. So let us get rid of that division. As we know, we are supposed to factorize, but first, please just make sure you introduce your multiplication there, because you might end up mixing a lot of things there. All right. So introducing multiplication, we understand we are going to invert the second fraction. It is the one that is going to be affected. All right. The first part, it remains as it is. So we're going to have 6x plus 3, everything over x squared minus 8x plus 16. All right. So if you're to consider, like I said, we are going to introduce a multiplication. It was not part of our question here. It was not part of our question. So the moment you introduce it, the second fraction, you have to change it, interchange it. You're going to take the denominator to be on the numerator now. So it's going to be x squared minus 5x plus 4, everything, the numerator to the denominator. So it's going to be over 4x squared minus 1. Already here, there's a multiplication, so nothing is going to change. We haven't introduced this multiplication. It was already given. So this fraction remains as it is, which is x minus 4 over 6x minus 6. So this is where you are. Everything is under multiplication. Then factorize. Then you can factorize whatever part that is applicable. All right. This is a linear expression. The first part that we have here. It's a linear expression. So you can simply factor out the highest common factor between 6 and 3, which is 3. 6x divided by 3, that is going to give us 2x. 3 divided by 3, that is going to give us a 1. All right, then we move on. We have a quadratic expression, and the coefficient of x squared there is 1. So remember, that is going to be our advantage. If the coefficient of x squared is 1, we know that we are going to have x, another x here. Then you simply consider the constant there, which is 16. We need the product factors of 16, which will add up to minus 8. So do we have products of 16, guys, which will add up to minus 8? Two numbers that you multiply, you get positive 16. So let's think of 4 and a 4. But in order for us to get a minus 8, it must be minus 4 and minus 4. Minus 4 times minus 4, that's a positive 16. Minus 4 plus minus 4, that's a minus 8. So meaning to say, we have a negative 4 and a negative 4 there. Minus 4, minus 4. Guys, the factorization of quadratic expressions where the coefficient of x squared is 1, make sure that you go through those basics. The revision is important. So let's move on to another part. Another quadratic expression, and also the coefficient of x squared is 1. So it was going to be advantage because we've got x and x here. Then we consider the constant. That's 4. Two products, which will give us a 4. But these products must add to negative 5. So that's we've got negative 4 and negative 1. 4 and 1 will give us 5. If we add, we are going to obtain a 5. But in this case, we need a negative 5. That's why we have to introduce negatives on these numbers. Negative 4, negative 1. If you multiply, you get a positive 4. If you add these two, you will get a negative 5. So these are the numbers that we need. Minus 4, minus 1. 4x squared minus 1 in the denominator. It is a difference of 2 squares. You can see that 4 is a perfect square. 1 is a perfect square. X squared is a perfect square. So what is the square root of 4? That is 2. The square root of x squared is x. The square root of 1 is 1. Remember, one bracket subtracts, another bracket is going to add. The square roots of what you have there. The square root of 4, the square root, you find the square root of everything. All right, that's a difference of 2 squares. Then moving on to another part there, we've got x minus 4, which is already in simplest form. There's nothing common there. 6x minus 6, 6 is common, so you can factor out that 6. So factoring out 6 here, we are going to remain with 6x divided by 6, that's x, minus 6 divided by 6, that's a minus 1. This is where you are. So introducing a multiplication, guys, it is because we are able to actually to reduce these fractions. So we just need a relationship there, which is to be taken between the numerator and the denominator. Are we having such? So if you consider here, we have got x minus 4 x minus 4. Numerator to the denominator. The same part. X minus 4, x minus 4. All right? We also have x minus 4 here, x minus 4 here. As long it is numerator to the denominator concept, you can cancel. In the numerator, we've got 2x plus 1. In the denominator, we've got 2x plus 1. We can cancel. In the numerator, we've got x minus 1. And the denominator, we've got x minus 1. We can cancel. In terms of the numbers, there is a 3. There is a 6. So we can reduce this one. 3 into 3, that is 1. 3 into 6, that's a 2. So as we can see, guys, in the numerator, we have got nothing left, just a 1, just like we've got a 1. So we're going to multiply 1 times 1 times 1 in the numerator. That was going to give us what? A 1. Everything over what? The denominator, what are we having? This is 2x minus 1. And there's a 2 there. So you multiply these two. So that is 2 into 2x minus 1. Remember, we have got the 2x minus 1 there. We cannot cancel anything that is, and now there's nothing that is left that we can cancel. So your answer is in simplest form. And there's nothing common in this bracket. So you must be very, very careful dealing with fractions. Factorization on its own, you're supposed to understand that. Factorization as a topic on its own. So revise the basics of your factorization. All right, moving on to another part, which is again working with the factorization part. That is 2.12. We are given that is a everything over 2a squared minus 3ab plus b squared. Then we've got minus, that's a b, everything over 2a squared plus ab minus b squared. So that's minus b squared plus 1 over ab, 1 over a plus b, like this. So these are algebraic fractions to be added. There's addition, subtraction at the same time. So it'll be easier if we have got these denominators being factorized. So in this case, we can see that the coefficient of our terms, this part of a squared, the coefficient is not 1. That's a 2. That's a 2 there. So that factorization that we simply have our brackets in an easier way, it can be complicated unless you know any shorter ways of factorizing. There are so many shorter ways. So those shorter ways, guys, is for you and your applications. It's for you and your applications, guys. If you understand that, please do apply it. So in this case, we're going to apply the longer way of our factorization. Let's hope you understand each other here. So this is 2a squared minus 3ab plus b squared. Remember, your longer way of factorization, guys, you multiply the first term to the last term if the coefficient of a squared there is not 1. So like I said, there are different methods, the cheat methods that you can use. Those ones are for your own good, just to understand them. But the longer way, this is how you're supposed to have it. 2a squared times b squared is going to give us 2a squared b squared. Remember, you multiplied first term to the last term. Then you look for two terms that will give you these 2a squared b squared when multiplied But when added, they are supposed to give you this term, the middle term, when added together. So do we have two terms? You multiply them, you get 2a squared b squared. So it's just like we've got 2ab and another one is ab. What you're considering is the number there, 2 and 1. If you multiply this, you're going to get 2a squared b squared. Remember, we've got a and a here, b and b. But if you add these, 2 plus 1, that's a 3, not minus 3. So for you to obtain a negative 3 there, it means we must have 2ab and minus 1ab. Minus, when I'm saying minus 1ab, it's just like ab minus ab. This is what we have. If we multiply these two, guys, we are going to obtain that 2a squared b squared. And if we add these two, minus 2 plus minus 1 like this, that's a minus 3. So we have exactly what is in the middle term. So what are you going to do actually with these terms? They represent the middle term. So you substitute them into the middle term. So that was going to be 2a squared. In place of the middle term, you substitute those terms. Minus 2ab minus ab, which is minus 1ab, is just like minus ab. You substitute into the middle term. The rest remains as it is. So we've got plus b squared. So if you consider properly, guys, you can see that we've got 4 terms. So when you're having 4 terms, remember factorization by grouping. We group this into 2, then we factor out the highest common factor between these 2 terms. So that's 2a, that's 2 and a there. All right, 2a squared divided by 2a is going to give us a, guys. You're simply canceling 2a squared divided by 2a. This will cancel a into a squared. We're going to remain with 1a minus 2ab divided by 2a. So that was going to give us minus b. Minus 2ab divided by 2a like this. This one and this one cancels. 2 and 2 cancels. So you remain with minus b. So on the other part here, we're supposed to factorize. Factor out what is common. B is common, very true. But we must have actually the same bracket as a minus b. So we cannot factor out positive b, because it will give us minus a plus b. As we need what? A minus b. So what are we supposed to factor out? We are supposed to factor out negative b here. So that negative will give you a positive. Minus b cancels, you get positive a. Positive, negative, that's a negative. So b squared and b, you obtain with a b. You remain with a b. What we need there is negative. Same as what we have in the first bracket. First bracket, there's a minus b. We're supposed to have the same thing here, so that we can factor out this common bracket of a minus b. By factoring out, or by taking out this bracket, we are going to remain here with 2a. And here we are going to remain with what? Minus b. That's another bracket. So these are the 2 brackets. So like I said, obtaining these brackets, these two brackets here, it can be by any way. There are so many different methods. Those are the cheat methods that you use, guys. We cannot refer them, but if you want, you can use any. What is important is that you write from this stage, all this factorization showing it is not even important. What they need is to have the brackets. Just after this, you can even write just after this, a over 1. That is the most important part. What you have obtained So it's going to be A over these two brackets from factorizing this. So that's A minus B, and another part is going to be 2A minus B. These two brackets from the factorization. So that factorization, guys, that one is in your hands. I do not know which method you understand, but at the end, you must have these two brackets and order. And also the order here does not matter. You can start with this bracket followed by this one. Does not matter. All right. So let's move on. There we're going to subtract. So that's minus B over 1. The whole of this factorized again. So you're going to have two brackets, just like what we had here. Then plus 1 over AB, this one. 1 over A plus B. This one is already in simplest form. So guys, let's factorize this. Have our two brackets. That's the part which I'm referring to say, guys, use any method of your choice. So I'm just going to go back to the longer way. Let's try to see this time what we have. Remember, first term to the last term. 2a squared times minus b. Remember, there's a negative there, so it's minus 2a squared b squared. We need two terms. When you multiply them, they are supposed to give you this minus 2a squared b squared. Two numbers. So we expect something like this, minus 2ab and ab, because it's supposed to give us a negative. One is supposed to be negative, another one positive, or 2ab and minus ab, because the product here is a negative. So one is supposed to be negative, one is supposed to be positive. But we need a condition that when we add, we are supposed to obtain this middle term, which is AB, same as what? 1AB. If you add, so is it going to be from minus 2 and 1? No. Minus 2 plus 1 is what? It's minus 1. That's minus 1. So we need 2 and what? Minus 1. 2 plus minus 1 is what? It's 1. So this one is going to give us AB at the end. So these are the terms that you replace into the middle term. So it is going to be 2a squared plus 2ab plus, we are here, plus 2ab minus ab. All right. Then we've got minus b squared at the end, like this. Grouping into 2. Remember, this is just helping us to have the middle term. Once the middle term is there, you group into 2. Factor out what is common between the two terms. So what is common here is going to be 2a here. All right. So if you factor out 2a, what are you going to have? 2a squared divided by 2a, that's a. 2ab divided by 2a, we are going to remain with the b there. It's like this, 2ab over 2a. So the 2a and the 2a is going to cancel. You remain with the b. All right. Then we move on to minus ab minus b squared. So you're going to take out the negative because here everything is positive. So you factor out minus b. Minus ab divided by minus b, that's positive a, minus ab over minus b, negative b and b. Minus b squared divided by minus b is going to be plus b. All right? Just like that. So the two brackets are the same. A plus b, a plus b. You take it out. This one, which is common. What are you going to remain with? You remain with 2a. What about here? You remain with minus b. These are the brackets that you're going to have after factorizing in any way that you understand. So we're going to have a minus b, 2a minus b. Remember, we are substituting here. So that's it. This is your factorization, guys. Your own way, your own understanding. We are done. You have these brackets. Now we are back to the normal simplification. How do we combine these fractions? We have to find the LCD, the LCM of the given denominators. So remember the LCM, you take everything that is given. We have a minus b A minus B. It's just repeating, just take as it is. So that's A minus B. We have 2A minus B. We have 2A minus B. All right, there's something weird here. There's something weird. I wanted to check if I did not. Let me see, guys. I think let me just, sorry for this. Sorry for this. I just hope I took this. All right, this is plus. This is plus here. Where did I get the minus, guys? This is a plus here. All right, very sorry for that. So this is 2A minus B here. All right, that's a plus there. When we simplify this, I was wondering to say, how are these two the same? All right, so you see, issue also in exam. You once you see something weird, guys, cross-check, all right? You see something that these two are just the same all of a sudden. From where? All right, anyways, guys, sorry for that. Let's see what we're going to have at the end. So that was going to be A minus B. We just have this one. We do not have any other A minus B. So that's A minus B there. 2A minus B. There is 2A minus B here. It's just a repetition. Just take it as it is. Then we have got A plus B here. A plus B here is just a repetition. Just take it as it is. So this is our LCD or the LCM of all these denominators that we had. Then what is that we need this? We just need to divide the LCD into this. So as you can see, guys, A minus B, A minus, this was going to cancel. But you assume as if you're canceling. You just assume as if you are canceling. Do not cancel what I'm doing there. Do not cancel. Just assume that these will cancel because they are the same. And you are going to remain with what? With A plus B. What you are going to remain with, this part, A plus B, you multiply it to the numerator. So it's going to be A into A plus B. So guys, that's it. A minus B, 2A minus B, 2A minus B. You remain with this one. The same thing if you check A plus B, 2A minus B, 2A minus B. You remain with what? With this one, with A minus B. Multiplied to the numerator, there's a minus there, minus B. So it's minus B into, remember we cancelled A plus B, 2A minus B, 2A minus B. We remained with what? With A minus B. We do the same thing here. A plus B, they cancel. So you remain with these two brackets. You remain with these two brackets, these ones. So it is going to be plus 1. The numerator, there's a 1. So it's plus 1 into these two brackets, which is A minus B into 2A minus B. These ones cancelled. But like I said, do not cancel. You just assume as you're cancelling. So this is where you are. Expand brackets in the numerator. Leave the denominator as it is. Focus on the numerator. So we are going to distribute all these. All right. Here there's a bracket. You have to expand. Here there's a bracket. You have to expand. But if you check here, guys, it's a repetition. This one. These two brackets here. These two brackets. A minus B. 2A minus B here. I want you to see that we have already calculated. We already had the quadratic expression, which gave us these two brackets. Remember that. If we go back here, this one here, where did we take this from? A minus B, 2A minus B. This is the same thing here. A minus B, 2A minus B. Where did we take it from? Here. This one. These two brackets. We took these two brackets from where? From this two, from this 2A squared minus 3AB plus B squared. So we are going to rewrite this one as it was, this one, in place of that one. All right? So guys, I hope you understand me there. This part of the brackets, remember you're supposed to expand, but we are not going to expand, re-expand. Well, we already had the brackets before, but if you want, you can expand. You still have the same thing. You have the same answer. All right. So let's start with the first bracket. A times A, that's A squared. A times B, that's AB. Minus B times A, that's minus AB. Minus B and minus B, that's going to be plus B squared. So this is 1 times the whole of this bracket, which is simply 1 times this. Remember, this is where we got it from. So it will just remain as it is there. So this one is going to remain as it is. 2A squared minus 3AB plus B squared, like this. Everything over what? Everything over the denominator, which is our LCD, the one that we got, our LCM. A minus B, 2A minus B, A plus B, just like that. Then simplify the numerator there. Are we having like terms? In the numerator, let's consider the part of A squared. All right, we have got A squared here, and we've got another A squared here. All right, this is a positive. So you just have to add there. Okay, that's it. So this is 1 plus 2, which is 3. So it's going to be 3A squared. All right, so that one is going to give us 3A squared at the end. Okay, then we have the part of AB. As you can see, this is canceling it. AB minus AB cancels. You remain with this one, minus 3AB, this one. This is the one that you remain with. So you're going to have minus 3AB. Then the part of B squared, we have this part of B squared, this one. This is B squared plus B squared. So it's just 1 plus 1, all right? This is just 1 and 1 here. This is just 1 and a 1. So 1 plus 1, that's 2. So it was going to give us 2B squared. Everything over what? The denominator that you're given there of A minus B, 2A minus B, and A plus B, just like that. So we have to check again. Factorization, remember, it's supposed to be in simplest form. So we have to check, is it possible for us to factorize the numerator? Remember that long away, if you multiply this and this, it was going to give us 6A squared B squared. Do we have two numbers that you multiply, you get a 6, but when you add, you get a minus 3? We do not have. 6 and 1, 3 and 2. There's no way that you get a minus 3 there. So meaning to say, these cannot be factorized. It's already in simplest form. So that is our final answer at the end. There's nothing that we can do. So in other cases, you see that after you've simplified like this, you see that there is a part which is maybe common, a bracket which is common. You divide. You can cancel those brackets. But in this case, it is not like that, guys. It is not like that. So this is your final answer. So that is what you had, guys. Look, they just give you these terms to confuse you guys. They know that if you're working with a lot of terms like this, you end up in confusion. Don't get confused, guys. These are just basic factorizations that you need to work with. So please do as much revisions as you can. All right, let's see another part. We were given on another part, which is 2.2. Given the following algebraic expressions, all right? 2.2.1, factorize each expression completely. Each is supposed to be factorized completely. All right, so let's start with the first one. This is our expression. Mn squared plus Mn minus 5n squared minus 5n. Remember we had the factorization when I was talking about by grouping. This is the exact part that we are supposed to use by grouping because we've got 4 terms. 1, 2, 3, 4. When you've got 4 terms, the best way is to group into 2. You factor out what is common between the first 2 terms. So that was going to give us mn. Mn is common. Then we divide. Mn squared divide by mn. M and m cancels. N into this, you remain with n. Mn and mn, that's a 1. All right. The last 2 terms, you're not just supposed to factorize. You factorize focusing on the first bracket because you're supposed to obtain exactly as what you have in the first bracket. So you're going to factor out minus 5n. All right. That's minus 5n squared divided by like this. Minus 5n squared over minus 5n. Cancels. N into this. You're going to remain with positive n. Minus 5n divided to minus 5n. Definitely it will be a positive 1 because these two are the same. They'll just cancel. As you can see, guys, the 2 brackets are the same. N plus 1, N plus 1. You factor out the N plus 1. You take it out. And what are you going to remain with? You remain with Mn. And what about this one? Minus 5n. Okay. Is this our final answer, guys? Can we say this is our final answer? No. Because in the second bracket, N is common. You could have factored out that N from the first place here. You could have done that. But to avoid that confusion, guys, you can still factorize that N at the end. This N here is common in the second bracket. So we are going to take it out. You factor that N out. So if we factor out N, it means we're going to remain with what here? If you factor out N, this was going to be M minus 5. All right. So this bracket you can just write as it is. N plus 1. It's not affected. Just rewrite as it is. So this is it, guys. You have factorized the first algebraic expression. Let's move on to another one. And 3m minus 15. That's another one. So another one is 3m minus 15. So this one is simply a linear expression. Factor out the highest common factor, which is 3. 3m divided by 3, that's m. Minus 15 divided by 3, that's a minus 5. All right. So this one is already done. It's already factorized. They just have to factor out the highest common factor. Then 2.22, they want you to determine the HCF and the LCM of the 2 expressions. What is going to be the HCF? Remember, I told you guys, the HCF is the one that you refer as the highest common factor, which is common throughout these 2. You check the final answers. You consider this part, the last part, here and here. Do we have anything common? Is it a number outside of a bracket? Is it a term outside of the bracket? Is it a bracket? So we can see that m minus 5 is the only term, is the only bracket that is common. So that's our highest common factor, m minus 5. Then the LCM, you take everything that you see. Guys, as long you can see it on these 2 brackets, on these 2 answers that you're given before, as long you can see it, you have to consider it. So here there is n outside of the bracket. Here there is 3 outside of the bracket. So we are going to take it as what? As 3n. Moving to the brackets, m minus 5, there is m minus 5 there. It's a repetition. You just take it as it is, m minus 5. Remember, you take everything. So do not repeat that one. It's just a repetition. Then we have got what? N plus 1. It's part of our brackets. So this was going to be our LCM. As long these terms are on your answer, it's correct. The order does not matter. You start with n plus 1. The order does not matter. Just like that. So questions can be given in this manner. You see your factorization is important. So if you check question 2, it's all about factorization. To simplify these fractions, you need to know your factorization. You need to understand your factorization. So this is the part. This is actually the core part of question number 2, factorization. Go through your factorization, guys. Understand the basics from linear expressions, quadratic expressions, which consist of the difference of two squares. It will be very, very important. So we just hope this one is for the sake of revision, guys. I'm not actually supposed to explain all this, but it is important also that we do understand these basics as we are revising. It will be of importance. So we're going to consider, let's check what we have there. So on question number 3, you were given to solve for n in the following equations. All right, 3.11, we've got our exponential equation there. These are exponents. So exponents, different ways of solving. Let's just have our question separately. So our question was like this, 3.11. You were given 1 over 8 is equal to 1 over 16 to the exponent of 3 minus 2n times 32 to the exponent of 4 minus 2n. So I always say when working with exponential equation and the bases are given like what we have in this case, we have got different bases. Try, guys, to work with the simplest form. Simplest form where you are working with the prime numbers 2, 3, 5, 7. So if you consider 8, 16, 32, all these numbers can be taken to the base of 2. You can take it to the base of 2. So 1 over 8 is same as what? Remember from your laws of exponents, guys, what made you to write this 1 over? It's from a negative. 1 over a certain number. Let's say we have got x to the exponent of n. It was taken from what? X to the exponent of a negative n. So this 8 that we see, it is just like we have got 1 over 2 to the exponent of 3. So if you rewrite in that form, it's same as what? 2 to the exponent of minus 3. So that's what we have there. 2 to the exponent of minus 3 is equal to 1 over 16. 1 over 16 is same as 1 over 2 to the exponent of 4. But the moment you take it this way, it will be 2 to the exponent of what? A negative 4. It carries a negative. But already there's an exponent here. 3 minus 2n. So do not forget that, guys. There's already an exponent there. 3 minus 2n times 32. It's already a whole number, but we need to write it in the same base of 2. So 32, remember, this is 2 to the exponent of 5. Raised to the exponent of 4 minus 2n. This is what we have. We have the same base at least. The base of 2. There's 2, there's 2, there's 2. All right, the left-hand side, let's just ignore it. 2 to the exponent of minus 3 is equal to, remember, from our laws of exponents, an exponent and an exponent like this multiplies x to the exponent of a raised to the exponent of b is equal to x to the exponent of what? ab. So you can multiply. So meaning to say there, it was simply a matter of distributing the minus 4 throughout. All right. So this is 2 to the exponent of minus 4 times 3, which is minus 12. Minus 4 times minus 2, that's a positive 8. So that's positive 8n. Times, still in the base of 2 on another part. Distribute again, because this is an expression, 4 minus 2n. So you must distribute this, multiply by 5. So that's 2 to the exponent of what? 2 to the exponent of 5 times 4, that's a 20. 5 times minus 2, that's minus 10. So it's going to be minus 10n. This is where you are. If you are multiplying now, like what we have here, where the bases are the same, you add the exponents, x to the exponent of a, when multiplied to x to the exponent of b, the law states that you add exponents. So meaning to say it is going to be 2 to the exponent of minus 3 is equal to, because of the same base under a multiplication. That is why we have to add the exponents. So it is going to be 2 to the exponent of, we take this one as it is, minus 12 plus 8n. You add this one as it is. So that's plus 20 minus 10n. You have combined these two. So let's add, guys. Simplify. 2 to the exponent of minus 3 is equal to what? Just going to collect the like terms there. That's 8n. All right, we can even start with the constants. It's up to you guys. Minus 12 plus 20. Minus 12 plus 20. That's positive 8. 8n minus 10n. 8 minus 10, that's negative 2. So this is where you are. You have simplified and you are at this stage. What you need is to calculate the value of n. But guys, you did your best to simplify everything. The right-hand side, you are simplifying. This is where you are. What is that you're going to do? Remember that. From our exponential equation, if the two are being considered to be equal with the same base like this, automatically the exponents will be equal. So in this case, therefore, it follows that the exponents, which is minus 3, will be equal to 8 minus 2n. Because the bases are the same. So you have a linear equation, guys. You can simply solve this one. All right, so this is it, guys. Take the 8 to the other side of the equation. This 8 is going to be a negative 8. So that's minus 11 is equal to minus 2n divided by negative 2. We've got a multiplication there. So we are simply going to divide by a negative 2. So n was going to give us 11 over 2, just like that. So that's 11 over 2, or as a decimal, you can write it as 5,5. So this is the value of n, which satisfies our equation. Once the bases are the same, you equate the exponents. It's a new equation on its own. You formed a new equation on its own once you have that. So you can actually substitute that. The value of n that you obtain, substitute it on the right-hand side. Simplify, you're going to get 1 over 8. If you do not get that, guys, then it means our n is wrong. All right, let's move on to another part on 3.12. You're given again to solve for n, this time on a log. Given a log. How can we solve for n? 1 plus the logarithm of n raised to the exponent of 3 is equal to 9. What can we do? There is an exponent there. The whole logarithm is being raised to the exponent of 3. Okay, let's get rid of this one before we confuse ourselves. So the logarithm of n, everything to the exponent of 3 is going to be equal to what? 1 to the other side, it becomes a negative. So that's 9 minus 1, which is 8. We can see, guys, exponent of 3. Remove that. The cube root, both sides. Just introduce the cube root. cube root here, the cube root here. Remember, the cube root cancels with this one. So we've got the logarithm of n equal to the cube root of what? Of 8. What is the cube root of 8? That's a 2. We know that. We can simplify that. So the cube root of 8 is equal to what? Is equal to 2. In the base of 10, because we understand if the base is not given, this is the base of 10. So you can calculate this change. Remember, guys, the ABC method, I've talked about these guys. Log A, B, C. Log A in the base of B is equal to C. Can be written in exponential form. This is the ABC method as A, this one. A is equal to B to the exponent of C. So this is ABC, ABC, ABC concept. Log A base B is equal to C is going to give us, which is, it is in two ways, from here to here, from log to this. As we are moving from where? A log. So we must convert to this one. So what is our A? This is our N. So it means N is equal to B to the exponent of C. This is B, the base B, 10 to the exponent of what? Of 2. Just like that. So therefore, N is equal to 100. So just like that. Just like that. N will be equal to 100. So guys, revise the logarithms. All the basics, they're important. Let's move on to another part. Given the logarithm of 2 is this, the logarithm of 3 is that one. All right, determine log 6 over 25 without using a calculator. Show all calculations. All right, that's an interesting question indeed. All right, 3.2, let's just take our information there. 3.2, we are given the logarithm of 2. All right. We are also given the logarithm of 3. We are also given the logarithm of a 5. Then we are asked to calculate or to determine log 6 over 25. Determine this log 6 over 25 without using a calculator. Show all workings. All right. So what is log 6 over 25? How can we simplify that one? Log 6 over 25. We understand that the laws of logarithms can be used to determine or to simplify even a certain log without a calculator sometimes, given information. Using the laws. Our laws states on a division of numbers. When we have a log like this and the numbers are being divided, when we have a log like this, log A over B, it means the logarithms were being subtracted before. The logarithm of A minus the logarithm of B. That was our case. That is what it means. So in this case, we have 6 and 25 divided together. So it simply means that's a logarithm of a 6 minus a logarithm of a 25. All right, this is where we are. A 6, we do not have it here. A 25, we do not have it. Let's say, guys, they gave you log 6, its value, and they gave you log 25. You are going to simply subtract. You're going to substitute the value for log 6. You subtract for log 25. But guys, they gave us something else. So what are we going to do? We are supposed to rewrite these 6 in terms of these numbers that we are given. One way or the other, those numbers are supposed to be there. So how can we obtain 6 from these numbers? There's a 2, there's a 3. So 6, it's a product of what? 2 and 3. That's 6. So you separate by multiplication or division. No addition. No addition here inside the bracket. It's either division or multiplication. Please take note. So log 6, that's log 2 times 3. Multiplication. The numbers are there, 2 times 3. What about log 25? Log 25, that's 5 times 5. 5 times 5 is same as what? Is same as 5 squared. Guys, if you multiply like this, 5 times 5, that's 5 squared. So let's use the laws at this stage. What is it about the laws? A multiplication. Remember, before we had a division. This time, there is a multiplication. The logarithm of AB was taken from where? Two logarithms which were adding together, the log of A and the log of B. So multiplying these two numbers here means you were adding logarithms. You were adding log 2 and log 3. That is what it means. You were adding these two. That is what it means. Log 2 and log 3. So let's drop our exponents, guys, and simplify here. Remember our log. If you're given something like this, log a to the exponent of n, it means n log a. The exponent, you drop it to multiply the log. So there's an exponent, which is 2. You drop it to multiply the log. So it's going to be minus 2, the logarithm of f5. Guys, once you see these logarithms separated in this manner, substitution can be done. You do not just substitute because there is a log there. You see that 2 times. No, we do not have log 2 times 3. We have log 2, log 3, log 5. So these are the separations that you need to make until you see these logarithms separated, each on its own, each on its own, each on its own, like this, so that you can properly substitute these logarithms. In place of log 2, you place what is equivalent to that. Log 2 is equivalent to what? It is equivalent to 0,301 plus log 3. Log 3 is equal to what? You are given. That's why because you are given, you are given what to use. So there you do not have any other way. You have to follow until you have what they are, or what they're giving you. What you are given until you have that. So what is log 3? 0,477. 0,477. Minus 2 log 5. This is a product. It simply means minus 2 times log 5. What is log 5? 0,699. Just like that. Until you see this, you substitute. They said do not use a calculator, guys. What are they simply trying to say here is that, okay, let me bring my calculator here. What are they simply trying to say here is that do not just take your calculator and simplify log 6. It was log 6 over 25. Do not just take your calculator and simplify like this, log 6 over 25. No. That is what they are saying. But at this stage, you can use your calculator, guys, to add, simplify this. You can even use your calculator, just like what we see here. We are going to have an answer approximately to this one. Approximately to this one. Remember our answers to 3 decimal place. Let's just shift this. Fix to 3 decimal place because they are on 3 decimal places. So fix the 6, 3 minus 0,620. This is the answer that you're supposed to get. At least approximate this one. You're supposed to get an answer like this. All right. That is what they are saying there. Do not use a calculator to take this and just simplify it once. But at this stage, you can use your calculator here. You can use your calculator. All right. So this is what you're going to get, guys. If you add these two on your calculator, you're going to get 0.778 minus, multiply these two, you're going to get 1.398. Then if you subtract, it was going to give you minus 0.62. Remember, our answers were to 3 decimal places, so you're going to put a 0 there so that you remain or you maintain the 3 decimal place concept, just like that. As you can see, this is exactly the answer that you had, but they do not want you to just use a calculator direct. No, they want you to simplify using laws of logarithms. Same with question number 3. You can just use your calculator here and get an answer, but they don't want you to do that. They don't want you to do that. They want you to properly apply laws of logarithms there to obtain the answer that you could have obtained using your calculator. So you see, guys, these questions. All right. So I actually explained about this part as a topic using logarithms to solve this type of a question. So here they are saying we are supposed to solve for m using laws of common logarithms. Common logarithms are just using a normal log that you are used to. All right, so let's take our question, guys. This is m is equal to this 3.3. All right, so m is equal to 9.18 to the exponent of 5 times 3.89, everything over the cube root of 2, 3. All right, that's 237.4. So they need you to solve for m, but using logarithms, meaning say you're supposed to introduce the logarithms. But you can just check on your calculator what was going to be an approximate answer. They do not want you to simplify it that way, but you can just check. All right, remember we fixed our calculator to 3 decimal places already. So let's just have our fraction here. That's 9.18 to the exponent of 5 times 3.89, everything over the cube root. So I'm just going to use shift the cube root. It's here on the square root there. All right, that's 237, comma what, comma 4. All right, so you're going to have an approximation of 40,000 957 comma 751, something like this. So we are going to use our logarithms and see, guys, if we are going to have an answer which is approximately in that range, in that interval. You're not going to get the exact answer because we are rounding off our answers, this and that. So we're not going to get exactly this one, but it must be approximately to this. So how do you go about it? I said you introduce the logarithms. You can first write your terms your numbers in terms of exponents. Avoid the cube root. Avoid those terms that are not part of your logarithms. Just find something that is applicable. So it is easier for us. We've got exponents. So we can just write this as m is equal to 9.18 to the exponent of 5 times 3.89. Everything over the cube root means to the exponent of 3. Remember that it means to the exponent of a third. Sorry, guys, to the exponent of a third, 1 over 3. So that is what I just needed there to have this exponent. Then we can introduce your logarithm. Remember, you need log. So you introduce a log on the left-hand side and on the right-hand side. Remember, it's an equation. Whatever that you do on the left-hand side has to be done also on the right-hand side. So we have introduced a log. The moment a log is being introduced, it means laws of logarithms must take place. So the logarithm of m is equal to what? There is a product there on top. Numbers are being multiplied. I talked about this, guys. If you're multiplying, it means you were adding the logarithms. Division, subtraction. So you can simply subtract separate that way. Multiplication is addition. So it's log 9,18 to the exponent of 5 plus log 3,89. It changes. You are multiplying numbers. It means the logarithms were being added. There is a division. So what does it mean? You are subtracting the logarithms there. Log 2, 37,4 to the exponent of a third. That's it. So we can drop the exponents. Remember, we saw this previously. When there was an exponent, we had to drop the exponent, drop the exponent. So let's drop our exponents. The logarithm of m is equal to, drop this, it is going to be 5. The logarithm of 9,18 plus the logarithm of 3,89 minus, you drop the exponent, so that's minus a third, the logarithm of 237,4. 237,4. So this is where you are. At this stage, you are going to simplify each log. Just try to simplify each. You simplify this. 5 log 9,18 on your calculator, guys. You can simply use your calculator, each and every part. Now you can use your calculator there. Remember, already we fixed our calculator to 3 decimal places. So whatever that you're going to have is to 3 decimal places. 5 log 9,18. 9,18. All right, so it's going to give us 4,814, just like that. So this is what you're going to have, 4,814. So you do that up to the end. Each and every part that you are given there, simplify it on your calculator. All right, so meaning to say log 3,89 to 3 decimal place, it was going to give us 0,590 minus a third log 237,4 was going to give us negative 0,792. So we are going to combine everything on our calculator. That's the logarithm of m is equal to, add these on your calculator. That was going to give us 4,612. 4,612. Remember, you need to calculate m, and we talked about this previously, in the base of 10. Remember when I was talking about that conversion, the log A, B, C concept, log A in base of B is equal to C can be converted as A is equal to B to the exponent of C. So this is M that we need. So that M is equal to the base B to the exponent of C. So that's 10 to the exponent of 4,612, which you can simply use your calculator to simplify that. So on your calculator, that was going to give you 40,926.066 to 3 decimal places. So it is the value of m that you're going to have. But remember, we simplified this before, everything on our calculator here. So it's 40,000. As you can see, it's approximately in that interval, 40,000 something. This is how it's supposed to be. You cannot get exactly the same answer as on your calculator, but it's supposed to be in within that interval because of the rounding off. You remember we were rounding off each and every part that we had. So that part alone, it affects your calculations, the rounding off. So you have to be very careful. The simplification. All right. So that was part of our question. Let's see another part. So on another part of our question, it was question number 4. All right. So this one you're done. The question number 4, which we are given 4.1, a waste paper bucket shown is, on the right hand side was built in the shape of a cylinder with a lid in the shape of that is a half of a sphere. All right. So the top, which is the lid, this is our lid. It is half of a sphere, meaning to say it is made up of what? A hemisphere, half of a sphere. Then the bottom part, which is this other part that we have there, which is the bucket that we have at the bottom there, is the cylinder. All right. So we have the cylinder, which this one, the top, the lid, this one is the half of a sphere, which is a hemisphere, but this is our cylinder. So that is the condition that we have there. It is made up of two shapes. The radius of the base and the top of the bucket is 16 centimeters, meaning to say on our base there, got a radius, 16 centimeters, same as on the top there. The radius is the same. All right, 16 centimeters. The height of the bucket is 50 centimeters without lid. Without this lid, this one, the height of the bucket, we are talking about this, the height of the cylinder. This is the height that we are talking about. So the height there is what? 50 centimeters. That's what we're given. So use this information now, or using that part that you're given there. You are supposed to calculate now the volume of the lid. That is, use the information given to calculate the following: 4.11, the volume of the lid. The lid is the hemisphere, this one, the top part. Take note. It is the hemisphere. As we know the volume of a sphere, all right, remember we are given these volumes here. Let me just go you guys to your formula sheet. As we know this volume of a sphere, the volume of a sphere is given as 4/3 pi r cubed. That's a complete sphere. What about a hemisphere? A hemisphere, that's a half of that. So the volume of the lid in this case, which is the hemisphere, is going to be half the volume of a sphere. And the volume of a sphere, we saw that it is 4/3 pi r cubed. Half of that. It is half. So that is going to be half times 4/3 times pi times the radius to the exponent of 3. That's 16 to the exponent of 3. We are already having our radius there. So just like that, you're going to obtain the volume of the lid, which was going to be 8,578,642 cubic centimeters. Remember, this is volume. All right, so that's it. 8,578,642. Just gonna write this. I need to remove this one. All right. So you just have to be careful there. What you're given. And 4.12, the volume of the bucket without the lid. The bucket without the lid. This is what? The cylinder. They want you to calculate the volume of the cylinder. That is what they want. And what is the volume of a cylinder from your formula sheet? That's pi r squared h. You're given that one on your formula sheet. So we're going to have pi times the radius. Remember, radius is 16. The height is 50. Just like that. So you're going to multiply this, and that was going to be 40,212,386. So that one, we have it. Then the total volume of the bucket and lid, meaning to say we just have to add there for the total volume. All right, just have to add. That's V total. We just have to add. So our V total was simply going to be this plus this one. That's 8578.642 plus what you got before, 40,212, 386. All right, so that was it, guys. You are already having the what? The volumes. So that was going to give us 48,791,028 cubic centimeters, just like that. So we have got the volume there. All right, this is cubic centimeters. So guys, be very careful answering questions. Then the total surface area of the bucket and the lid. The total surface area of the bucket and lid combined together, these two. When you are dealing with surface area, guys, it is what you see on the outer part. What is it that we see on the outer part? We do understand that the total surface area of a cylinder on its own, it was supposed to be given as 2 pi r squared plus 2 pi r h. We have this in a formula sheet also. But this time we cannot use this formula since the top is no longer open. It's not closed with a circle. No, it is closed with a hemisphere. So we cannot use 2 pi r squared. We are going to use pi r squared only for the base in the base here. There's a circle there. So we are going to take pi r squared. Only one circle plus the curved part of our cylinder, which is 2 pi rh. So this is the part of the cylinder only. What about that part that we removed here? What are we going to replace with? We replace with a hemisphere here. A hemisphere. How do you calculate the surface area of a hemisphere? Remember, the surface area of a complete sphere, it's 4 pi r squared. A complete sphere, it's 4 pi r squared. What about a hemisphere? When it is being cut like this part only here, it is going to be half of this. So half of this is going to be 2 pi r squared. Remember, we do not take this way. Remember, a hemisphere is supposed to be like this. Then there's also supposed to be a circle here. We cannot take this part of a circle because it is the one that is already covered. This space, it will be open here. You don't take it. When you talk about the surface area, you talk about this outer part, what you see. If it was just a normal cylinder closed like this, it was going to be pi r squared, pi r squared. But we cannot take this pi r squared here. It is just an open space that is not to be taken. So we are going to use or take 2 pi r squared. All right, so be careful on that part. So you're going to take 2 pi r squared. This is the part of a hemisphere. not complete. You have to use, that is the, you see, when you are working with the solid shapes, you apply the question. Surface area is what you see on the outer part. So here it's covered with a cylinder, with a hemisphere. So this one is not to be taken because it's already covered on the outer part. So that is what you're going to have here. The formula has changed. You adjust the formula according to the information that you're given. So as you can see, guys, we've got like terms here, pi r squared and pi r squared. So that's 1 plus 2, which was going to give us 3 pi r squared plus 2 pi rh. You can even just substitute. I'm not saying it's wrong, but you can also add before the substitution, then substitute your values. That's 3 pi times the radius. Remember, the radius is 16. So that's 16 squared plus 2 pi r. The radius is 16. So you're going to multiply to the radius. All right, let me just open a bracket here. The radius is 16. The height, remember the height is 50. You're already given this one. That is the height, which is 50. So that's it. You are going to obtain the total surface area. So that was going to give us 2368 pi square centimeters, or as a decimal, 7,439,291. All right, this is surface area measured in square units, meaning to say you're going to have that in square centimeters. So apply questions, guys. Understand your questions. So that was it. Then on another part of question 4.2, you're asked to use the mid-ordinate rule to calculate the area enclosed by x is equal to 0, x is equal to 17,5. That is from to this one. So remember that your area, this one is just direct, guys. Remember that your area from the formula sheet, we are going to use the first plus last ordinate, first plus last ordinate, which are the values of y in this case over 2. These are the y values plus the sum of the other ordinates. All right. So there we are going to have the sum of the other ordinates. So we're going to have the sum of the other ordinates. This is what you're going to have, the sum of the other ordinates that are remaining, or the remaining ones, times the distance between. I'm just going to use d, the distance between. So this part here, this one, it is all about the y values there. This part, it is all about the y values. And this one, it is all about the x values. Remember that. So meaning to say, when talk of the x, this is x, like we've got x1, x2, x, whatever that we have. The y values from 4 to 6 to 8 to 11 to 17 to 12 to 10 to 9. These are the y values. So if we are saying the first plus the last ordinate there, what is the first ordinate for the y values? That's a 4. Plus the last ordinate and the y values, which is what? A 9. Over 2. Plus the other ordinates, which is the remaining ordinates. What is remaining? We're remaining with what? 6. We take the y values. There, we've got 8. There, we've got 11. Plus 17. Plus, there's a 12. There's a 10. These are the remaining ordinates. Remember, this is our last ordinate. Just like that. Then the distance there, D, is the one for the X values, the difference in X values. Between the X values, there is going to be a constant difference throughout. The first one is 0, 2,5. There's a difference of what? 2,5. 2,5 and 5, there's a difference of 2,5. 7,5 and 5, there's a difference of 2,5. 2, so you're going to have that difference throughout 2,5, 2,5, 2,5 throughout. That is the D there from the X values. So there's a difference of 2,5. Okay, guys, so that was it. Just like that. You simplify. This is now you and your calculator are going to simplify. 4 plus 9 over 2 was going to give us 6,5. 13 over 5, which is 6,5. Then you add everything after that. That was going to give us 70,5 times the 2,5, which is outside there. So multiplying these two guys, we're going to have your area. So that was it. That was going to give us 705 over 4. All right. Or as a decimal, 176,25 square units. All right. So remember, this is area, and area is being measured in what? In square units. So there you use the square units. So it's all about the formula, understanding the formula, what it means on your formula, substituting the values. Okay, once you understand the formula, guys, what it means, then it's not going to be difficult because that substitution was already there. It's just a matter of inserting the values. So moving on to question number 5, there we are given a function. All right, that is given the function of f of x, where y is equal to x squared plus 8x. From this function, you are being asked, does the point -3, -6 lie on the graph of f, which is on our f of x? Does it lie? If a point lies on a function, it simply means that point correspond, the x value must correspond to the y value. What am I trying to say? If we substitute this x value, which is -3, we must obtain our y value as -6, this one, if it lies on a point. So that is what you're going to test. That's how you test. So when x is equal to what? -3, as we are given there. Our x is -3. Y is supposed to be what? According to our function, what is the value of y? We substitute there. So that's in place of x, gonna have -3 squared plus 8 times -3. In place of x, remember, you are substituting a -3. That's the case there. So multiplying these two guys, we're just gonna simplify this on your calculator. You are going to obtain -15. This is exactly for the value of x when it is -3. Y is supposed to be -15. But here, our y value is -6. So that means, that alone means this point does not lie on a function. It is not found on this function. Okay, so that's -3 -6 does not lie on f of x. Does not lie on f of x, on this function of x that you're given. All right. So that was it for this question. Moving on to the other part, you were being given 5.12 to determine the y-intercept of the function. Remember, the y-intercept, it's on a condition where x is equal to 0. So when x is equal to 0, y is equal to what? In place of x, just substitute a 0 there. So that was going to give us a 0. So that's our y-intercept. Determine the roots of the function on 5.13. So the roots of the function, we do understand these are the values of x. When y is equal to 0, we solve this equation. It must be equal to 0. X squared plus 8x must be equal to 0. All right, that's to solve an equation. So this is a quadratic equation. You can use factorization. X is common. Factor out x. X squared divided by x, that's x. 8x divided by x. This was going to cancel. You remain with 8. That's equal to 0. So one of these brackets or one of the terms is supposed to be equal to 0. X is supposed to be equal to 0, or x plus 8 is equal to 0. So that means x here is going to give us what? -8. There we've got a 0. So these are the values of x, which represents the roots. X is equal to 0, or x is equal to what? A -8. All right, just like that. Then considering another question, we are given to determine the axis of symmetry of the function, the axis of symmetry. That is what we have there on 5.14. So we can use our formula. Remember from your formula sheet, if you are to determine the axis of symmetry from your graphs here, we can use the minus b over 2a for the axis of symmetry, minus b over 2a. Yes, you can do that. All right, let me just show you guys so that we will be on the same page. So there we can use minus b over 2a. X is equal to minus b over 2a. Remember from your quadratic equation, ax squared plus bx plus c is equal to 0. So this is x squared plus 8x is equal to 0. The coefficient of x squared is your a. The coefficient of x is your b. So meaning to say x is equal to minus b, the coefficient of x, minus 8 over 2 times a, which is 1. So that was going to give us -4, right? Or you can simply use this concept. Remember, I said at the axis of symmetry, the value of x is equal to x1 plus x2 over 2, where x1 and x2 are the roots of the function, where x1 and x2 are the roots of the function. So taking 0 plus the other root, which is -8, divide by 2, you are going to obtain a -4, same value as what you obtained there. That is for the what? The axis of symmetry. Remember, at the axis of symmetry, that is where our graph is actually having the turning point. If your graph is like this at the axis of symmetry, the value of x is the one that corresponds there at the turning point. So where x is -4, that's where we have our turning point there. So they're asking you on 5.15 to determine the y-ordinate of the turning point of the function. Why not the turning point? Because already the x value is there. So they just need the y value. This is what I'm trying to say. At the axis of symmetry, the value of x there is the one that you use. That is the one that be at the turning point, at the axis of symmetry. So meaning to say, we just have to substitute the value of x at the axis of symmetry, which is -4, into the function. Remember our function, y is equal to what? Y is equal to x squared plus 8x. But x is what? -4. So that's -4 squared plus 8x, 8 times -4. So that was going to give us the value of y at the turning point, which is -16. All right, so y value was going to be -16 at the turning point. Then from there, you are being asked to use the system of x's provided. All right. So there was given an addendum there attached. But yeah, I do not have, guys, to draw this graph. Indicate all intercepts with x's and turning points. I'm just going to show a sketch of how it was going to be like 5.16. Let me just try to have it here. So remember your graph, guys, you are going to have definitely your y-axis and x-axis. All right. So let's say I've got our x-axis here. This graph is more to the negative. So let me have more values on the negative side. All right. That's 0 there. Remember, that's our y-axis. This is our x-axis. So I do not know, according to your addendum, guys, how were you given the scale here in terms of x, the values for x, but here I'm just going to use 2 for 6, 2 for 6, minus 2, minus 4, minus 6, minus 8, minus 10. Then for the y values, I'm just going to use 5, 10, 5, 10, and so on, and so on. All right, so going down, I'm just going to use the same scale, minus 5, minus 10, minus 15, minus 20, something like that to accommodate minus 16. This is the value of y that we have, which is in the negative minus 16 there. All right, so remember, what is important, first, the type of the graph that you're given there. We are given y is equal to x squared plus 8x. The coefficient of x squared is a positive. We are having a positive, so this is going to be a smiley shape like this, all right? That is what we know, something like this. All right, so let's just remember the roots. We have the roots at 0 and at minus 8. It's important. The y-intercept, remember the y-intercept at x is equal to 0, y is equal to 0. So the y-intercept is where the root is. That is where also the graph is going to pass. So the graph is going to like have something like this to say, when it is going to the turning point, then it will go back to that point. That is the condition. Remember, the turning point is at a condition of x value at the axis of symmetry at minus 4, and the y value of the turning point is minus 16. So minus 4 and minus 16. Let's just say approximately it was going to be somewhere there as your turning point. So this point is minus 4, minus 16 on your graph. Please be very careful there. That's a turning point. So meaning to say, our graph can be drawn because we have got the roots and also the turning point. So our graph was going to be like this to the turning point. So we've got our turning point, then it goes back to pass through the other root, which is also our y-intercept at the same time. So we're going to have a sketch, something like this, all right? So these are the intercepts, minus 8 and the 0, and also this our turning point at the same time. So that was our f of x, all right? Okay, just write f. So that is it, guys. Then another part was to, all right, let's move on. 5.2. It was given, all right, given the function of g this time, which is this one, is equal to 0. 5.21, draw the graph of g on the same system of axes used for question 5.16 on addendum A, on the same addendum there that is given. Draw that line. All right, so as you can see, g there is a straight line. So let us just have our gx. That's a straight line. All right. So our g of x, we are given, that's a straight line. 2x plus y plus 16 is equal to 0. As you can see, the highest exponent there is a 1. That's a linear function. And on a linear function, we understand what is important is to know the x-intercept and the y-intercept. These are the most important part. The x-intercept and the y-intercept. These two. For the x-intercept, we know that y is supposed to be equal to 0. So when y is equal to 0 here, solve for what? Solve for x. If y is equal to 0 here, solve for x. So it means we're going to have 2x. There's nothing there. That's a 0 there. So you're going to have plus 16 is equal to 0. What is the value of x? 2x is equal to minus 16 divided by 2 by 2. So x is equal to minus 8. Remember, 16 to the other side changes. So this is our x-intercept at minus 8. So it passes through this point at minus 8, x-intercept. The y-intercept, we do understand it's on a condition where x is equal to 0. So when x is equal to 0, there's nothing here. So we are going to remain with what? Y plus 16 is equal to 0. So what is the value of y? 16 to the other side? That's minus 16. So the y-intercept is at minus 16. Minus 16. This is supposed to be as here, somewhere around there, approximately here. Let's say this is where we have our negative 16. So that's it. X-intercept at minus 8, the y-intercept at minus 16. These two were enough for us to have the straight line. Remember, a straight line can be drawn with these two. You just have to join your x-intercept to the y-intercept with a straight line that's using a ruler. That's forming a straight line, something like this. Okay, guys. So yes, just because I'm using freehand, but you guys were using a ruler. So it was going to be something properly drawn on your side like this. All right. So you guys do the exact thing like that. So that is our g of x. You can just write g on that function. All right. So that was your question. You draw that one. You just join on your graph. And after that, they were asking you to read from the graphs, from the two graphs that you've drawn, and write down the coordinates of the points of intersection of f of x and gx. The coordinates at the point of intersection of f of x and gx. Remember, our f of x is the quadratic and gx the straight line. So at the intersection, where are they intersecting? They're intersecting here at minus 8. Remember, here it's already a point of intersection. And this one, it's a point of intersection. But what will be the x value? For you to obtain the x value, you are going to take this point with your ruler straight, going to the x-axis, straight to the x-axis. The corresponding value there is the one that you need. The corresponding value there is the one that you need. The corresponding value. So we need what? The points of intersection, 5.22. All right, so this is 5.22. So the first one is at minus 8, meaning to say that's minus 8, 0. The value of x there is minus 8, y, 0, because it's in the x-axis. And another one, we saw this one. So according to your graph, it was going to correspond exactly at minus 2. Right? It was going to correspond exactly, guys, at what? At minus 2. Then the y value is the one that you're going to take corresponding. So you're going to have the y value from there. That was the condition. So it was going to be, sorry for this. I'm just going to substitute. It was going to be at minus 12. It was going to be minus 12. So here I'm not having a graph, guys, but for you, you'll be having a graph so you properly see that point. So it was going to be minus 12. So that's it. These are the points that we are being asked there, the coordinates of what? Of the points of intersection. All right, so just like that. Then 5.3, we are given this function hx and the one for k, which is given from 0 to 180. 5.31, copy and complete the table below in your answer book. So you're going to copy this, then complete. So you're going to start with hx, this part of hx. Remember, hx is the graph of what? 2 cos. So this one, guys, we're just substituting on your calculator. Make sure that your calculator is in what? Is in degree form. You're just substituting in place of x. You substitute a 0 there. You substitute these values that are given. So if you substitute a 0, guys, it was going to give us a 2. If you substitute 16, it was going to give us 1. At 90, it was going to be 0. At 120, minus 1. At 180, minus 2. You do the same thing on the graph of kx. This one for kx. Remember, kx is now minus 2 cos x. So in place of x, this is where you're substituting your values. If it is 0, you substitute a 0 there on your calculator. So this was going to give us -2, -1, 0, 1, 2, just like that. So it was just a matter of substituting direct on your calculator. And after that, you were going to draw the graph according to the information, the table that you're already, the graph that was already given, or the system of x's that you're already given in that addendum. But in this case, I do not have, so I'm just gonna have a sketch. You were gonna have, I do not know according to your graph how it was given, but definitely you will be having the x values and the y values. So with the spacing of what you're given, that's 0, 30, 60. This is the spacing that you have. So you're going to have 30, 60, 90, 120, 150, 180 degrees. Then going up, you can see the bigger value is 2. The smaller value is -2. So you're just going to have maybe 1, 2. Just going to write 1 and 2. All right, let's say this is where we have our 1 and our 2. All right. Then going down, we're going to have the same -1 and -2. All right. Then we have to mark these points. Let's start with H. This one for HX. So you just have to mark these values 0 versus 2, 0 versus 2, 30 versus 1,7. Something is just an approximation. Maybe it's somewhere there. All right. Then 60 versus 1, 60 versus 1, maybe somewhere here. 90 versus a 0. 120 versus -1, maybe somewhere there. All right. So I just hope it's not going to affect my presentation, guys. You know, these boards. All right. Let's just hope. Okay. Then 150 and -1,7, something somewhere around there. 180 versus -2, somewhere around there. So this is it. It's not a straight line, this one. It's not a straight line. It was just going to be a curve like this. All right. Using freehand, it was just going to be a curve. Sorry for this here. Guys, it's just because here I'm not having exact but it was going to be like this. All right. So this is your H. You do the same thing for the KX, mark the points. This time it's gonna be 0 versus -2. So that's -2 somewhere there. -1,732 at 30. Somewhere there. 60 versus -1. 90 versus a 0 there. 120 versus 1 on top there. 150 versus 1,7 on top there. 180 versus 2 on top like that. So that is it. Again, it's not a straight line. It's just going to be a curve, something like that. So you're going to have something like this. So they are intersecting at that point, something like this. All right. So this is the one for KX, just like that. So the question was just for you to draw. Nothing special after that. There's nothing that they're asking there. So that was it. Let's see another part of our question, which was question number 6. On question number 6, you're given the first part, 6.1. What do you understand by 1 radian? So 1 radian, that's a measure. That's like a rotation that is being taken. So it's simply a radian, the unit of measure for angles. In SI, unit of what? Of units. In SI, of units. A rotation that is happening there. So I don't know, guys, just gonna write in your own words what you understand by a radian. The area of a sector of a circle is, so we are talking of a sector. Remember, a sector is just a piece of a circle. Like on a circle, we just take a piece like this one. So they gave us the area of that sector, that it is 64 square centimeters. Given that the angle of the sector subtends at the center of the circle is twice its radius. The angle here called theta, it is twice the radius, 2 times, that is twice. So it is equal to 2r. Theta is equal to 2r. That is a statement that you are given there. Okay? So with that information, calculate the following: 6.21, the radius of the circle. So definitely here, according to our information, we can use the area. That is what we only have. Remember a sector. Okay, let me bring you back to your formula sheet so that we'll be together here. Remember a sector is given on top. I think, yeah, supposed to be on top. A sector. It's here, guys. Somewhere here. I just want you to understand these basics. So that will be here. All right, it's just hidden here. This is the part of a sector. The area is equal to half r squared theta. There's a formula there. All right, let's take that formula because it represents the area, the one that we are given. All right, that's 6.21. Remember, you need to calculate the radius. You do not know the radius, but you are given that the area is equal to half r squared theta. In terms of the radius, we can substitute our values. We have the area, 64, is equal to, remember, we want to have this in terms of the radius. So there is no substitute for radius. You can just going to write as half r squared times theta. Theta. Remember, theta is the angle, and we are told that it is 2 times the radius. It is twice the radius. So in place of theta, we can substitute 2r so that our equation is in terms of r. That's it. We have formed an equation. We can solve for r. So 64 is equal to what? Half of 2. This is going to cancel. R squared times r. That's r to the exponent of 3. So remove that exponent of 3 by what? The cube root. So you're going to have the cube root both sides. What is the cube root of 64? That's a 4. And this simply neutralizes. So that's we're going to have r there. So that's the radius is going to be what? 4 centimeters. A circle, which gives us this sector, it has a radius of what? 4 centimeters. All right, just like that, guys. You see, they know that if they give you direct information, they just give you all values. Then they ask you to calculate the area, the formulas, they just substitute. You're going to totalize. So now they want you to form equations with the information that you're given. Then the angle subtended at the center of the circle. If we have the radius, therefore the angle can be determined. Remember the relationship between this angle. Theta is equal to what? 2r. We are given this relationship. So it's 2 times the radius we calculated. Remember, we got 4. So 2 times 4, it's 8. This is in radians. When this formula is being used, theta will be in radians. So it means 8 rad. Then 6.23, the arc length of the sector, the arc length. All right. Remember, we have theta now, which is 8 rad. So the arc length can be determined. If you consider the other formula there, okay, let me bring back to the formula sheet. You see this formula. It is giving us a relationship between the arc length, this formula that is given here. Theta is equal to arc over radius. Theta is equal to arc over radius. What are they trying to say? Okay, let me write down the way that they wrote it there so that you understand it also. Theta is equal to arc over radius. The arc is the arc length. So we can find it by simply making the subject cross multiply. So meaning to say the arc length, which is our arc, is equal to what? Theta times radius. So it's simply radius times theta. Theta in radians. So what is your radius? You have it. That is 4 times theta. Remember, we calculated theta. We said it's 8. So 4 times 8 was going to give us 32. So that's our arc length. So that is 32 centimeters. Remember, these other units are in centimeters, 4 centimeters. So that will be also in centimeters as we are given these other units. Just like that. All right. Let's see another part, which is 6.3. We are given a wheel of diameter 700 millimeters. There is a diameter there. Diameter 700 millimeters. Rotates at an angular velocity of. This is measured in rad per second. That's our omega, angular velocity. 80 rads per second. With this information, the question is asking you to calculate the following: the peripheral velocity, the linear velocity, that is the one they want there, in meters per second. How do you convert from rad per second to meters per second? Remember, I talked about this conversion from rad per second to anything that is in angular can be converted back to linear by multiplying by the radius. So V is the linear velocity is equal to radius times omega, our angular velocity. We have converted to meters per second. So radius is supposed to be in meters. So radius, they were given diameter. So we're going to divide 700 over 2. This is in millimeters. Convert it to meters. We simply remove this milli that we are given. So you multiply by what? 10 to the exponent of -3. That is converting to meters. We have converted to meters there. Times our omega. What is our omega? Our angular velocity is 80. So this converts it automatically to meters per second. That's our V, which was going to give us 28 meters per second. Just like that. Then on 6.32, the distance a point on the circumference of the wheel covers in 9 minutes. What will be the distance? Guys, already you are given a relationship. You're already having a relationship. From this V velocity, 28 meters per second. 28 per each second. We cover 28 meters per each second. So what is going to be the distance? Remember, distance is simply velocity times what? Times time. So you take the 28, you multiply the time per second. There you are given 9 minutes. So you must convert that to seconds. 9 times what? 9 times 60. Remember, in a minute, we've got 60 seconds. So you have to multiply by 60 the number of minutes that you're given there. That's giving us the distance in meters. So it was going to give 15,120 meters, just like that. All right. So guys, be very careful when answering questions. Okay, that's it there. All right. 6.4, you are given to calculate the length of the chord of a circle. The length of the chord, we are back to this part of our formula sheet here, where where it is explaining about the segments of circles. Here, if you do not know your information, this is where you take it. The chord length is x, the height of the segment h, the diameter d. Then this is the formula that you can use to calculate the diameter, to calculate whatever that you want. You can make it the subject from there. All right. So in this case, we are asked to calculate the length of the chord. We saw that the length of the chord is x. So we need to calculate x. Given the diameter is there. They gave us the diameter, 15 centimeters. The height of the segment created by the chord is 10 centimeters. They also gave us the height, which is our h, 10 centimeters. So on that formula, you saw that the formula is given for the diameter. D is equal to h plus x squared over 4h, like this. As you need to calculate the value of x. So it's either you're going to substitute, then you make x, you solve for x, or simply make x the subject. So as for me, guys, since we want to calculate x, I'm just going to make x the subject. All right, take h to the other side is going to be d minus h is equal to x squared over 4h. So we need to remove this 4h. It's in the denominator, so just multiply by it. Multiply by 4h. The whole of this part, you're also going to multiply by 4h. So this will cancel. So to find x, definitely you're going to introduce the square root, both sides. So therefore, our x was going to be written as the square root of 4h into d minus h. They can even ask a question where they ask you to, like this, make x the subject. Here, they did not ask it like that way, but you can do that, or you can just substitute the way that I was explaining, that you can just substitute as numbers. So there now you can substitute. Or you could have just substitute in the initial place. What is d? D is 15. So 15 is equal to h, which is 10, plus x squared over 4h. Our h, remember, it's what? It's 10. Just like that. So that's, take the 10 to the other side. 15 minus 10, that's 5. So 5 is equal to x squared over 4 times 10, which is 40. This is over 1. So we're going to cross multiply 1 times x squared. X squared is equal to 5 times 40. So we're going to have the product there of 200. Then introduce the square root both sides to find the value of x. So x was going to be the square root of 200, which is 10. Square root of 2, or as a decimal, it was going to be 14,142 to 3 decimal places. That's our x. You could have just substituted direct, or you make the subject just like here. Then you substitute now the values of x. I mean, the values that you're given to find x. That is 4 times h. Remember, our h is 10. So that's 4 times 10 into d, our diameter, 15. H is 10. So that's d minus h. So it's 15 minus 10. 15 minus 10 is something like 5. So it's going to be square root of 40 times 5, of which 40 times 5, guys, it's 200. So square root of 200, that's the same answer, 14,142 centimeters. Just like that. You can make the subject of the formula, or just substitute and solve it as an equation like this. And all these ways, all these in your hands, guys. 6.5, you are given in this triangle ABC that we do not see, that we do not even see here. So let's have it. But take note, B is 90 degrees. So it's a right angled triangle. It's not just a normal triangle that you just draw like this. No. B is 90 degrees. So there's a right angle there. So I'm going to call this angle B, since that's where my right angle is. So I'm going to call it ABC. There's a 90 degrees there at B. All right. AC, 72 centimeters from A to C. This one, AC, 72 centimeters. Angle C, 63 degrees. Angle C, this one, 63 degrees. This is what you're given so far. 6.51. So you can actually, here you can calculate angle A. Remember, angles in a triangle, guys, they add up to 180 degrees. So you can even calculate angle A. Angle A is going to be 180 degrees minus this angle of 90 plus 63 degrees, which was going to be 27 degrees. You can even calculate this angle here, 27 degrees if you want. Then you can even use that angle. But in this case, I'm going to use the one that we are given, this one at 63 degrees. This one. This is the one that I'm going to use. So the first question was to calculate the value of BC. BC. So according to 63 degrees, according to this angle of 63 degrees, this is my opposite. AB is the opposite. BC is the adjacent. Right? This one does not change. 72, guys, is the hypotenuse, the one that faces what? The right angle. So I need BC, which is adjacent, given hypotenuse. So which formula am I going to use, guys, from the SOHCAHTOA, from those ratios? SOHCAHTOA, which is adjacent and hypotenuse. Adjacent hypotenuse, that's cos. All right? So that's cos of theta, which is cos 63 degrees, is equal to what? Adjacent over the hypotenuse. Adjacent, which is your BC, over the hypotenuse, which is 72. So, guys, we formed an equation. Solve for BC, because this is the same as over 1. You can have any number, whatever is a trig function can be written as over 1. So let's find BC. Cross multiply. That's it. Okay, so what are we going to have, guys? This is not affecting at the end. 1 times BC, that's BC. 72 multiplies cos 63. So it's 72 cos 63. Just like that. So that's it, guys. On your calculator, you can simplify this to 3 decimal places. That was going to give us the value of BC, which is 32,687. All right, in centimeters, just like that. Same application can be used to calculate the length of AB. Using this angle of 63 degrees, AB is the opposite, given what? Hypotenuse. Or since you calculated BC, you can even use Pythagoras theorem. It's up to you. But I'm going to use the trigonometrical ratios. AB is the opposite, and I have hypotenuse. Opposite hypotenuse. So that is for what? For sine. So we are going to use the sine of theta. All right. So that is the sine of theta, which is our angle, 63 degrees, is equal to opposite over hypotenuse, opposite, which is AB, over the hypotenuse, 72, just like that. So that is it. So if you are using 27 degrees, it changes, guys. According to 27, this is your opposite, and this is your adjacent. According to the angle of 27, it changes. So use these ratios properly. Here I'm using 63 degrees. All right. Anyways, guys, let us cross multiply and find our answer there. 1 times AB, that's AB, is equal to 72 times sine 63, that's 72 sine 63. So that was going to give us the value of AB, which was going to be 64,152 centimeters, just like that. So guys, be very careful. On another part, you are given to find the value for tan of A. So tan A, you can find your angle A. We have a 27, so it's simply tan 27 degrees, which is 0,510. Or you can substitute the values that we obtained on our calculation. Remember, we calculated these the BC, we obtained these values. BC was 32,687. AB was 64,152. So the tan of angle A, according to angle A this time, opposite. This is our adjacent. This is our opposite, guys. This is our adjacent. So remember the ratio of a tan. So the tan of angle A, remember the ratio of a tan, opposite over adjacent. So you're simply going to substitute what is our opposite. 32,687 over what? Adjacent, which is 64,152. This is according to angle A. According to angle A, this is your opposite. You name the side according to the angle. Remember, when it was 63, this was our opposite. You name according to the angle, these sides. All right? So meaning to say, dividing these two, you're going to obtain 0, it was going to be like this, 0,50952. But if you have already fixed your calculator to 3 decimal places, it's just going to give you the answer. But this was going to change into a 10. That's a 1. So that's 0,510 to 3 decimal places, just like that. So this is the tan of A, opposite over adjacent. On another question, you are given 6.6. If the cos of theta is square root of 3 over 5, theta being taken from 0 to 90 degrees, meaning to say we are talking of what? The first quadrant from 0 to 90 degrees, where all ratios are positive. Remember from the cast concept, all ratios, they are positive. Okay? So we're just going to have our triangle here because this is a ratio. So definitely it was taken from what? A right-angled triangle. So theta, I'm just going to put our theta here. This is cos, remember, from your soccer tour. From your soccer tour, cos adjacent over hypotenuse. So this is adjacent over the hypotenuse. According to theta, this is our adjacent. This is our hypotenuse. So that's adjacent, square root of 3, the hypotenuse, which is 5. Remember, this is opposite. So this is our triangle. And they want you to find tan theta. And tan, as you can see, it's opposite over adjacent according to our ratio. Tan theta, it's opposite over adjacent. So we need opposite. According to theta, this is our opposite. So you are going to calculate this side. From where? Pythagoras theorem. You are given two sides. You want to calculate the third side. Hypotenuse squared is equal to side squared plus side squared. Hypotenuse is what? It's 5. So 5 squared is equal to the shorter sides. Just gonna use, there's square root of 3 there. So you're gonna have square root of 3 squared plus b squared. 5 squared, that is 25, is equal to square root of 3 squared, that is 3. All right. This is plus b squared. So take the 3 to the other side. It's going to be 25 minus 3. 25 minus 3, which is 22. All right. All right, all right, all right, all right. Where am I getting the 5? Where am I getting the 5? Okay, this one. All right. Sorry that, guys. I just used a 3 somewhere there, but it's supposed to be what? A 5 there. Okay, which is fine. So that's it, guys. So that's gonna be 22 there. If you subtract this, which is equal to b squared, they definitely introduce the square root. So b is equal to the square root of 22, which is b is the third side, which is this other side that we're calculating. So that is the square root of what? 22. So the question was calculate the tan of theta. So tan of theta being opposite over the adjacent, meaning to say this is opposite, adjacent, opposite, square root of 22 over square root of 3. Remember, when dealing with sets, this is the same thing as square root of 22 over 3 like this. Right? It's just the same thing. It's just the same thing, which you can simplify on your calculator as a decimal, or just leave it under the square root, or you can have it as a decimal. If you can simplify this, it was going to give us something like square root of 66 over 3 on your calculator, which is as a decimal is something like 2,708. You can just write any answer in any way that you understand, but that is how you're supposed to have it answered. So that is how our questions, guys, will be given. Let's continue to revise as much questions as we can. In what? In light. Everything shall come to clarity as we are revising. So that's it, guys, from Maths Zone African Motives. Till we meet again.